Hello everybody, this is part 3 of my HP Chromebook 14 troubleshooting. So just to bring you up to speed, this is a HP Chromebook 14 that does not switch on. I don't have a charger for this, so I needed to inject power. So I located where the battery management IC was, which is this one here, which is a BD99954. I identified where the power comes in on this, which is this point right here from the USB. And when I found where the power comes in, I injected my own 15 volts right here. I injected the 15 volts and watched it come through Q3 and Q4 across my current sense resistor, which is Q3, Q4 current sense resistor, up to this high side, low side MOSFET configuration, which is these two MOSFETs here and coming out at the inductor. So after this inductor, we watched the voltage coming through and out to system voltage here, at which point I measured 8.8 volts. Now this is just the sample circuit for this BD99954 IC. This is not a schematic for the entire motherboard of this laptop, but it seems like it's pretty close to what we're looking at here. So what I have is I have 8.8 volts at this point, and we're going to track and see where the 8.8 volts goes. Okay, so we're in search of 8.8 volts at other points across this motherboard. As I said, we have it at this point right here. And I measured around the board and I found 8.8 volts here, obviously because it's only through a fuse, but I think this is off to the battery. I found it over here on this IC as well. Now this looks like a dual MOSFET, which is controlled by this chip right here. If you zoom in, I also found 8.8 volts on the pin of this chip right here. I was able to measure at that capacitor. Where else did we see it? Yeah, there was also 8.8 volts down here at this other IC. I'm not sure what this is for or what's controlling it. But I guess the overall point is that this 8.8 volt system voltage right here is present at a number of other positions on the board. So it seems that our main 8.8 volt power rail is making it across to the other components on the board. So we've established that our system voltage is online and that it is present across the board to all of the other secondary circuits. So where to next? Well, what I wanted to focus on next was seeing if whatever the battery voltage is on this, it's usually 3.3 volts on the bigger laptop, so I presume it's 3.3 volts on this. But I wanted to see if that secondary 3.3 volts always on voltage is present on the board somewhere. On the bigger laptops there's also a 5 volts always on, but I'm not sure, this is smaller, so I don't know if it has all of the exact same voltages as a bigger board. But what I found was there's this chip right here. It's a T65094A. And when I found the datasheet for that, that's what it is here. TPS65094. And as you can see with this, it has 3 LDO regulators with adjustable output. Just the sort of chip that you might expect to provide you with a 3.3 volts always on and possibly a 5 volts always on. And there's a third one there if you wanted it as well. So I just wanted to get a look at the pinouts of this IC and see if we could find, number one, that it's getting an input voltage, and secondly, to see if we are getting our always on voltages from this IC. I've just screen grabbed the pinouts from the datasheet, and what we can see is that there's a VSys right here. And if I check that from the datasheet, it tells me that pin 55 is VSys. It's an input. It's got I's and O's across here, but that's for input. And it says system voltage detection and input to internal LDOs 3.3 volts and 5 volts. That's what we were looking for. Okay, so it's used to detect that the system voltage is there and to provide the input from which is generated a 3.3 volts and a 5 volts. So what we need to measure here is to find that pin 55 and see if we have system voltage on that. Now, of course, trying to find the 55th pin on this is a bit difficult given there's so many pins on it, but we look and find pin 1, which is right beside this dot here. So we're counting from 1 and going this way, and where I find pin 55 is right here. Okay, so that is the one that they have marked as VSys. Alright, let me just double check that on the printout here. So that is from the datasheet. Now again, the datasheet has the dot here, so we need to rotate it so that it's the same with the dot up here as it is on our circuit diagram, or on our actual scan, sorry. You can see that 55 is here, and that corresponds to this pin right here. So when I measured volts DC, the easiest spot for me to measure here was actually out at the cap, because this is actually tiny as well. It's a lot smaller than it might seem on the screen here. So I measured at this point of the capacitor, and what I found was that there was 8.8 volts here. So that is the system voltage that we've generated, and it is present at this chip. So we have input. So the next thing is to check and see if we have those LDO outputs. And this is where our pinouts from the datasheet come in handy once again. So as you can see, we have our VSys on 55, and if you look right beside those, you've got LDO3P3 and LDO5P0. That's pins 54 and 56. And if we go back to our datasheet, 54 and 56 are, where are they? They're here somewhere. 54 and 56, yeah, 54, LDO3P3 is O for an output, 3.3 volts, output of 3.3 volts internal LDO. Okay, and then 56 is LDO5P0, which is also an output, 5 volts, and this is the output of the 5 volt internal LDO. So these are our 3.3 volts and 5 volts always on. So even without powering the laptops, I should be able to measure the two of these pins and find 3.3 volts and 5 volts respectively on those pins. So back to our motherboard. We have already identified VSys as being pin 55, and now we have pin 54, which is our LDO3P3, our 3.3 volts LDO. And pin 56 we have identified from the datasheet that this is LDO5P0, which is our 5 volts always on. So again, in volts DC range with my black probe to ground, which is out of picture here because I've had to zoom in so much, I decided that I would measure not at the pin right here because there was too much of a chance of shorting the two like here. So I decided that I would track it out here to this capacitor. And when I measured here, I found that there was 3.3 volts. Similarly with the LDO5P0, I didn't want to measure right here in case I would cross a couple of these pins and just blow the chip. So all of these power rails tend to have a capacitor, and I measured on this capacitor right here, and I found that there was 5 volts there also. So where are we now? Well, what we've identified is that our main power rail, our 8.8 volt system voltage as it is called here, is reaching this chip, and this chip, part of its job is to generate a 3.3 volts LDO always on voltage and a 5 volts always on, and they are both present. So this chip is doing its job. Okay, so this 3.3 volts is most likely to be seen on the power button, and we're going to check for that next. Okay, so we need to find where the power button connects to the motherboard in order to check the voltage on it. On the older laptops there used to be a daughter board that was just for the power button, and it was really easy to check because it only had like 2 or 3 pins on it. However, now the power button, as you can see here on this one on screen, it's incorporated as part of the keyboard. So we need to check the pins coming in from the keyboard connector, which is this connector here, which is on the other side of the motherboard. Now there's a lot of pins here on this, so you have to go one by one and find out which one is for the power button. So what I did was I got my black probe, I placed it to ground, I got my multimeter in volts DC in the 20 volts range, and I went with my red probe pin by pin on this connector here. And what I found was that a number of them had 3.3 volts on the pin, but when I went to pin 3, I measured 3.3 volts here, and when I pressed the power button, that went to 0. Okay, so that's what's meant to happen. You're meant to see 3.3 volts on the pin going to the power button. When you press the power button, it goes to 0. So what does this tell me? Well, that tells me that there is no issue with the power button. The power button is sending the signal to the motherboard, but the motherboard is not reacting to that. Okay guys, that's where I'm going to leave this one for this week. I hope that we're all making a bit of progress on this. I know it's pretty painstaking and I'm going over old ground, but I think it's going to be worth the work in the end. Next week I've got 2 laptops coming and I've got 2 ATX power supplies. I've bought them all and they're being shipped to me. They're all from different customers, so hopefully I should have some interesting content where I can just go through a quick fix for next week's video. But please like and subscribe, and if you've got any comments for me, please post them down below, and I'll see you next week. Thanks.